Look at your hand right now. Really look at it. You see those little ridges, those swirls, the fingerprints. You think that is a solid object. You think it stops where the skin ends. It doesn't. Right now, your finger is exploding. Every second, millions of molecules, your oils, your moisture, your dead cells, are erupting from your skin into the air. You are a volcano of particles, and you are surrounded by a cloud of yourself. You are like a man watching a symphony orchestra through a soundproof glass window, seeing the violins move, seeing the conductor's hands, and thinking you understand the music. But you hear nothing. You are missing the entire performance. And here is the secret that nobody tells you. Here is the thing that we usually leave to the dogs and the bloodhounds, because we are too proud, too civilized to admit it. You can detect that cloud. You, a human being, I, with your supposedly weak little nose, can track a person across a room just by the physical debris they leave behind. I know this because I have done it. I didn't use a machine. I used my nose. We are going to talk about the physics of smell, the physics of fingerprints, and why you are walking through a universe rich with information that you are choosing to ignore. Let me show you what your finger is really doing. If you could see the world as it truly is, the jiggling atoms, the vibrating energy, you would see that your finger is exploding. Right now, this second, every second you are erupting. You are a volcano of particles, oils, moisture, dead cells, organic molecules. They are vibrating so hard, jiggling with so much thermal energy, that they break loose from the gravity of your skin and fly out into the air. You are surrounded by a cloud of you, a cloud of fingerprint stuff, drifting outward, expanding, mixing with the air around you, and you don't even know it. Now here is the thing that nobody tells you. Here is the secret that we usually leave to the dogs and the bloodhounds because we are too proud, too civilized to admit it. You can detect that cloud. You, a human being with your supposedly weak little nose, can track a person across a room just by the physical debris they leave behind. I know this because I have done it. I didn't use a machine. I didn't use fancy equipment. I used my nose. I know what you're thinking. No way. I can't smell anything from my fingers. And you're right. You think you can't smell it. But that's because nobody ever taught you to pay attention. The physics says otherwise. And we're going to prove it. We are going to talk about the physics of smell, the physics of fingerprints, and why you are walking through a universe rich with information that you are choosing to ignore. Let me show you what your finger is really doing. But before we get down on our hands and knees, literally, I want you to ask yourself something. Why do you think you can't smell? Who told you that? Was it a biology teacher? A textbook? They told you that the human sense of smell is atrophied, weak, useless compared to a dog. They lied. Or to be more precise, they didn't run the experiment. They assumed. And in science, we don't assume. We look. This isn't just about smelling a book or a hand. This is about waking up. It is about realizing that the air around you is not empty space. It is a thick soup of matter. A chaotic dance of billions and billions of atoms. And you have a detector right in the middle of your face that is sensitive enough to pick up a single molecule. One molecule. Out of billions. So here is what we're going to do. We are going to follow Feynman's approach. Experience first, theory after. We're going to understand how evaporation works at the atomic level. Why your fingerprint is a source of flying molecules, Then we're going to watch a man, me, get down on the floor at a party and sniff books until he finds the one you touched. Then we're going to go deeper. Into the atomic mechanism, into why you think you can't smell, into the chemistry that's hiding in a penny. And by the end, you will see yourself differently. Not as an observer standing outside the universe looking in, but as a participant, playing the game, when exchanging atoms with everything around you. If you want to stop being a spectator watching through soundproof glass, if you want to hear the music, we are going to find things out together. We are going to learn how to see with our noses. You put your finger on a glass table, you press down, you take it away. And if your hands are even slightly warm, and they are because you are alive, you leave something behind. A smudge, a fingerprint. The police look for these. So crime shows love them. But have you ever stopped to ask, what is that smudge actually made of? It is made of atoms. Now I need to tell you something. If all of human knowledge were destroyed tomorrow, every textbook, every hard drive, every lecture ever recorded, and we could only pass on one single sentence to the next generation, it should be this. All things are made of atoms. Little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. That is Feynman's sentence, the most important sentence in all of scientific history. And it is the key to understanding everything that follows. Now imagine these atoms on your fingertip. Right now. Look at your finger. Those atoms are not sitting still like bricks in a wall. They are shaking. They are jiggling. They have temperature. And temperature. This is beautiful. Temperature is just a measure of how much they are jiggling. The hotter they are, the more they jiggle. On your skin, you have oils, sebum, moisture, water molecules, amino acids, a whole chemical cocktail that is uniquely, specifically you. When you press your finger against the glass, some of those molecules get stuck. They adhere. Why? Because of electrical forces. The same forces that hold every atom in your body together. But here is the thing nobody thinks about. Those molecules don't stay there forever. You know what evaporation is, right? You see a puddle of water on the sidewalk. The sun comes out. An hour later, the puddle is gone. Where did it go? Did it vanish? Did it cease to exist? No. The water molecules were jiggling around. Every once in a while, one of them gets hit by another one at just the right angle, with just the right energy. Bang! It picks up enough speed to break free from its neighbors. It escapes. It flies off into the air. That is evaporation. And that is what smell is. Think about that for a moment. Right now, the oils on your fingertips are evaporating. Molecules of you are floating into the air. Can you sense that? When you touch a book, you leave a trace of oil. That oil is slowly evaporating. Molecules of you are rising, drifting, mixing with the air. And when a bloodhound comes along and sniffs, what is the dog actually doing? The dog is sucking that air into its nose. Those flying molecules crash into the chemical receptors inside the dog's nasal cavity. It is like a key fitting into a lock. The molecule has a shape. The receptor has a shape. They click together. A signal fires to the brain. And the dog says, without words, without thought, "Ah, Richard was here." We accept this for the dog. We nod our heads and say, yes, dogs have incredible noses. But here is the question that changed everything for me. Do we? Can we do the same thing? I know this because I have done it myself. I was at a party once. I used to go to parties, believe it or not. And at this particular party, we got into an argument. Someone, I think it was a biologist, said, "Humans have no real sense of smell. Compared to a dog, we are practically nose blind." And everybody nodded. Because that is what the textbooks say. That is what your biology teacher told you. Humans, weak nose. Dogs, super nose. Case closed. But I didn't buy it. I had been thinking about this. I thought, maybe the problem isn't the equipment. Maybe the problem is the distance. We stand on two legs. We are up here, 5 or 6 feet above the ground, breathing the clean air. But the good smells? The heavy molecular trails? They are down there, on the carpet, on the floor. The dog is down there. We are up here. So I said something that changed the rest of the evening. Let's run an experiment. Everyone laughed. Cheers, they thought I was joking. You think you can smell like a dog? Someone asked. There was this look, you know the look that says, this man is either brilliant or insane. I said, you can argue philosophy all night long, or you can do the experiment. That is the only way to know. The room went quiet. Not because they believed me, because they were curious, and curiosity. That is the most dangerous thing in a room full of people with drinks in their hands. We got a stack of books. I told everyone to leave the room except me and the host. Then the guests came back in, one by one. One person, I didn't know who, picked up a book, held it in their hands for a moment, and put it back down. Then they all stood in a line, and I got down on the floor. I am talking about hands and knees, on the carpet, at a party, in front of people I was supposed to impress. I crawled over to the books. I put my nose right against the cover. I mean physically pressing my nose against the paper. The first book. I breathed in deeply. Nothing, just paper, dust, old glue, the kind of smell that means nobody has been here. The second book. Nothing, same paper, same dust, same emptiness. The third book. There it was, a dampness, a warmth, something alive. It wasn't strong like perfume or cologne. It was subtle, the way a whisper is subtle compared to a shout. But it was unmistakable. It smelled like life, like moist atoms that had been pressed against the paper by a warm, living hand just minutes ago. I said, "It's this book." Then I went to the line of people. I felt ridiculous. I looked like a dog, and everyone was laughing, but I was dead serious. Science doesn't care about your dignity. I sniffed the first person's hand. No match. Second hand, no match. Third hand. Click. The same smell. The same collection of molecules I had found on the book. The same chemical signature, transferred from skin to paper to air to my nose. You touched the book, I said. And I was right. I did this with Coke bottles too. Glass bottles. I could tell which bottle a person had handled just by smelling the glass. Not by looking at fingerprints. By smelling them. Now, why does this matter? Why am I telling you a story about a man crawling on the floor at a party, sniffing books like a bloodhound? Because it changes your map of reality. Still, you walk into a room and you think the room is empty. But if someone was there 5 minutes ago, the room is full of them. Their molecular trail is physically hanging in the air. The fingerprint isn't just on the surface anymore. It is dissolving, evaporating, drifting into the atmosphere. And for a brief window, before those molecules spread too thin, your nose can catch them. You have always had this ability. You just never got down on the floor to use it. Think about the air for a moment. We treat air like it is nothing. Oh, it is just empty space, invisible, irrelevant. Something you walk through on your way to the door. It is not. Imagine you are standing in a hailstorm, but the hailstones are invisible, and there are billions of them. Billions hitting every square inch of your face every single second. That is air pressure. That is nitrogen and oxygen molecules smashing into you, bouncing off, smashing again. Bing, bang, boom. Perpetual motion, perpetual bombardment. You don't feel it because you have been living in it your entire life. It is like a fish not noticing water. But the bombardment is real. It is physics, and it never stops. Now, mix in the fingerprint molecules. A guy named Joe walks into the room. He touches the door handle. He leaves a smear of oil, his specific chemical signature. Those oil molecules are sitting on the metal surface, and they are jiggling. Remember, everything is jiggling. The atoms from the air slam into those oil molecules. Nitrogen hits oil, oxygen hits oil, over and over. And every once in a while, smash. The collision is hard enough that an oil molecule picks up enough energy to escape. It pops off the surface. It joins the air. It drifts. Air currents, which are just big mobs of atoms all moving together, carry those molecules across the room. They tumble. They bounce off walls. They spread out. And 5 minutes later, Joe's fingerprint isn't just on the door handle anymore. It is everywhere. The whole room has a thin, invisible fog of Joe in it. Now you walk in. You breathe. And what happens when you breathe? You are bringing the outside world inside your body. You are taking a physical sample of the universe. Those molecules, those little pieces of Joe's fingerprint. They go up your nose. And every breath you take right now, you are inhaling millions of molecules from everything around you, including the person sitting next to you. Deep inside your nose, there is a piece of machinery called the olfactory bulb, and it is more sophisticated than any chemical detector we have ever built in a laboratory. It is directly connected to the brain. In fact, it is the only sense where the brain is practically exposed to the outside world. No middleman, no translation layer, direct contact. The molecule hits a receptor, and here is where it gets beautiful. It is not just a bump, it is a chemical interaction. It is electrical. The shape of the molecule determines the signal. It is like a hand fitting into a glove. If the glove fits, the nerve fires. Signal. We have a match. We have detected Sweaty Joe. The brain gets the signal. The data arrives. Joe was here. The physics works perfectly. Your nose did its job. But here's the problem. Here is why you think you can't smell. Your brain gets the signal from the olfactory bulb. The data is clear. Joe's molecules are in your nose. The receptor fired. The nerve sent the message. Everything worked. And your conscious mind says, I don't care. I'm busy looking at my phone. I'm busy looking for the exit sign. I'm busy reading a text message. I don't have time for smell. We filter it out. We suppress the data. We are drowning in information. Visual information, auditory information, tactile information, and somewhere along the way, we evolved to ignore most of it. The visual cortex is a bully. It takes up almost all the processing power. Your eyes demand so much of the brain's attention that everything else gets pushed into the background. Smell, pushed aside. The nose sends the signal, and the brain says, not now, I'm watching something. But the data is there. The physics is working. The atoms are hitting your nose whether you pay attention or not. The question is not whether you can smell. The question is whether you are listening. When I did that experiment with the books at the party, all I did was turn off the filter. I told my brain, consciously, deliberately, listen to the nose, ignore the eyes, focus on the data coming from the olfactory bulb. And suddenly, the world opened up. It was a new dimension. You have had this dimension available your entire life. You just never knew to look for it. Imagine if you could see the wind. Imagine if you could see the trails of heat rising from a coffee cup. You know when you look at a hot road in the summer and the air wiggles? That shimmering? That is the changing density of the air bending the light. That is atoms moving faster, spreading out, warping space around them. Smell is similar. But instead of light bending, it is particles traveling. If you could visualize the air in this room right now, it wouldn't be clear. It would be a chaotic, swirling fog of history. You would see trails of where your cat walked 10 minutes ago. You would see a plume of burnt toast particles hanging near the kitchen, even though the toast is gone. You would see a cloud of detergent molecules coming off your own shirt. We are swimming in a sea of history. The past is physically present in the air around us, slowly dissipating, slowly spreading out due to entropy. But it is there, right now, all around you. And your nose, that supposedly weak, useless organ, can read it, if you let it. Let's go deeper. Let's look at the mechanism, the jiggling that sends the fingerprint into the air at the atomic scale. You have a surface, a table. It looks smooth. You run your finger across it, and it feels flat, polished, clean. It is not. If you could look at that table under an electron microscope, zoom in 1,000,000 times, it would look like the Alps, jagged mountains and deep valleys, ridges and crevasses at the molecular scale. Nothing is smooth, nothing is flat. It only looks that way because your eyes are too big to see the truth. Now you put your finger down, you press. The oils from your skin, your sebum, your moisture, your unique chemical cocktail, get squished into those valleys. They settle into the crevasses like water pooling in mountain ravines. The oil molecules are trapped, but they are not dead. Remember? Everything is jiggling. These molecules are still moving. They are stealing energy from the table beneath them. They are stealing energy from the air molecules slamming into them from above. Every collision transfers a tiny bit of kinetic energy. And then it happens. A nitrogen molecule from the air hits an oil molecule at just the right angle, just the right speed. Smash. The oil molecule absorbs that kinetic energy. It thinks, if molecules could think. Great. I have enough energy to escape. And it pops out. It launches off the surface and joins the air. This is a statistical process. It is probability. We cannot say which molecule will pop out next. We can only say that on average, a certain number will fly off every second. This is what physicists call vapor pressure, and it is happening right now on every surface you have ever touched. That is why you can smell rain before it arrives. The molecules are already escaping. You have always detected them. Now consider the bloodhound again. The bloodhound has a long nose, lots of surface area, lots of receptors. But the fundamental physics is the same as yours. The dog is just sampling the statistical distribution of these flying molecules. And here is what the dog is really doing when it tracks a criminal. The dog is doing calculus. The dog is detecting a gradient. Over here, 500 molecules per cubic centimeter. Over there, 502 molecules per cubic centimeter. The difference is 2 molecules. 2. And the dog's brain says, "Chica, and the trail goes that way." The dog doesn't know calculus. The dog doesn't know physics. But the dog is a physicist. It is solving the problem of diffusion experimentally. Walking through a gradient field and following the math without knowing it is math. And you are a physicist too. You just forgot how to use the equipment. But it goes deeper than that. Because there is something about smell that separates it from every other sense you have. Something that changes who you think you are. We humans, we are strange creatures. We separate ourselves from nature. We say, there is the physical world out there, and then there is me, the observer, in here. We draw a line. Inside, outside, subject, object. But you are not separate. You are made of the same stuff. You are a pile of atoms observing other piles of atoms. And when you smell something, when you smell a fingerprint, something extraordinary happens. It is not like seeing. When you see a star in the night sky, you are seeing light that left that star 1,000,000 years ago. You are not touching the star. There is a vast distance between you and the thing you perceive. Vision is remote sensing. But smell is direct contact. When you smell a fingerprint, you are physically ingesting pieces of the object. The molecules travel from the surface, through the air, into your nose, onto your receptors. The distance is bridged. The object has come to you. It is inside you now. This is why smell is so emotional. Why the smell of your grandmother's house hits you like a wall. Why the smell of rain on hot asphalt stops you in the middle of the street. Why a stranger's perfume can break your heart. Smell skips the logical brain. It goes straight to the amygdala, the ancient, primal part of your brain that deals in raw emotion and memory. There is no analysis, no filtering. The molecule arrives, and the memory explodes. Think of a smell that takes you back to childhood. You didn't choose that memory. The molecule chose it for you. Now, I want to challenge you. I want you to try something. Take a coin, any coin, rub it in your hands. Really get your sweat on it. Press your fingers into the metal. Wait a minute. Then bring your nose close to it. Don't touch it with your nose. Just hover. Close your eyes. Shut down the video feed. Focus everything on the sensation in your nostrils. Can you smell the metal? Here is a fun fact that will rearrange your brain. You cannot smell metal. Metal does not evaporate well at room temperature. The atoms in a coin are locked tight in a crystal lattice, a rigid, organized grid of atoms holding each other in place. They do not jiggle loose easily. The vapor pressure of copper at room temperature is essentially 0. So what are you smelling when you smell a coin? You are smelling yourself. The metal acts as a catalyst. When the copper and zinc on the coin's surface come into contact with the oils on your skin, they trigger a chemical reaction. The metal rips apart the organic molecules on your skin and breaks them down into smaller volatile compounds, ketones, aldehydes, that evaporate instantly and fly into your nose. You are smelling your own biology being transformed by the metal, a chemical factory happening right under your nose, on a penny. Isn't that marvelous? It is not just a smell. See, it is a collaboration between your body and an object. Your atoms and the coin's atoms, interacting, reacting, producing something neither could produce alone. When you start thinking like this, when you see chemistry happening on every surface you touch, the world becomes infinitely more interesting. How can you be bored when there is a chemical factory on a penny? How can you be bored when the air is full of the ghosts of fingerprints? We talk about the universe expanding, galaxies moving apart at unimaginable speeds. But there is a universe right here, on the tip of your finger. We talk about the cosmos, galaxies spinning, stars exploding, the universe expanding at billions of light years in every direction. But there is a cosmos on your skin. At the micron scale, a millionth of a meter, your fingerprint is a landscape. Ridges like mountain ranges, valleys filled with oil, colonies of bacteria living in the crevasses like cities in the canyon. And it is all moving, all jiggling, all exchanging atoms with the air. But here is the part that should make you stop and think. It fades. Everything fades. That is the second law of thermodynamics, entropy. The universe moves from order to disorder, from concentrated to spread out, from information to noise. Your fingerprint on the glass? Right now, those oil molecules are escaping, one by one, jiggling loose, drifting into the air, mixing with billions of other molecules, spreading thinner and thinner. Sweaty Joe's trail? It was strong 5 minutes after he touched the door handle. An hour later, weaker. A day later, gone. Not because the molecules disappeared. They are still out there somewhere, bouncing around the atmosphere. But they are so spread out, so diluted, so mixed with everything else, that no nose, not yours, not the dog's, can find them. That is entropy, the great eraser. The reason smells fade, the reason fingerprints dissolve, the reason the past becomes invisible. Every smell you have ever loved is still out there, scattered, dissolved into the universe, gone but not destroyed. The information doesn't vanish. It spreads. It becomes part of the background noise of the cosmos. Your grandmother's kitchen, the rain on the asphalt, Sweaty Joe's door handle. All of it, still here, just too thin to read. And that is beautiful. And that is sad. And that is physics. But you had a window. A brief window where the signal was strong enough to catch. And you missed it, because nobody told you to listen. Until now. This is what Feynman meant when he said he wanted to find things out. Not memorize things. Not collect facts like stamps in an album. Find things out. With your hands. With your nose. With the raw machinery of your own body. Remember the orchestra? At the beginning, I told you, you are like a person watching a symphony through soundproof glass. Seeing the violins move, seeing the conductor's hands, but hearing nothing. Now you can hear the music. Not because I gave you new ears, not because I upgraded your hardware. Your nose was always this good. Your receptors were always this sensitive. The olfactory bulb was always wired directly to your brain. The equipment was never the problem. The problem was that nobody ever said, "Pay attention, get down on the floor, put your nose against the book. Close your eyes. Listen to what the molecules are telling you." You thought you were an observer, standing outside the universe, looking in through the glass, separate, detached, watching the show but never hearing the music. You are not an observer, you are a participant. Every breath you take, you are sampling the universe. Every surface you touch, you are exchanging atoms. Every room you walk into, you are reading the molecular history of everyone who was there before you. You are not separate from the physical world. You are in it, made of it, trading pieces of yourself with it every single second. And once you see that, once you really feel it, You cannot go back to the soundproof glass. The music is too beautiful. So let's bring this all together. You started this video looking at your hand. Just a hand. Skin and ridges and fingerprints. You thought it was a solid object. You thought it stopped where the skin ends. It doesn't. Your finger is a volcano. Millions of molecules erupting every second. A cloud of you, expanding into every room you enter. And for 35 minutes, we have been learning to detect that cloud. We watched the atoms jiggle loose from a fingerprint on glass. We got down on our hands and knees at a party and sniffed books until we found the one a stranger touched. We followed Sweaty Joe's molecular trail from a door handle across an entire room. We rubbed a coin and discovered we were smelling ourselves, our own biology, transformed by metal. We learned that the air is not empty, it is a bombardment, a thick soup of history. And every smell you have ever loved, your grandmother's kitchen, rain on hot asphalt, is still out there, scattered across the universe, gone but not destroyed. And through all of it, the equipment was never the problem. Your nose was always this good. The olfactory bulb was always wired directly to your brain. Nobody told you to pay attention. Until now. You are not an observer watching through soundproof glass anymore. You are a participant, playing the game, exchanging atoms with everything around you. The glass is broken, the music is playing, and all you have to do is find things out. If this changed how you see the world, even a little, hit subscribe. Leave a comment and tell me, what is the first thing you are going to smell differently after watching this? I'll see you in the next one.